Hi guys, welcome to another video, and in this lesson we're focusing on the Group 1 metals. The Group 1 metals are found at the far left side of the periodic table, and they're sometimes referred to as the alkali metals. From our previous video we learned that elements that are in the same group will have similar chemical properties, and this is because they all have the same number of electrons in their outer shell. For Group 1, you need to know some of the common properties about these elements. So let's start off with some of the common properties first before we get into their reactions. Some of the common properties for Group 1 elements is that they all have a very low density. And this can be seen when we put these Group 1 metals in water. That you may have seen these reactions at school where lithium, sodium and potassium, they all float on top of water. They're all quite soft, which means that we can easily cut them with a knife. And as we go down Group 1, the elements get more reactive. For example, potassium will react a lot more violently than lithium. You may have seen these reactions in your school where lithium, sodium and potassium are added to water, and the reaction gets more violent as we go down. Rubidium and cesium are class 2 dangerous for schools, and francium's radioactive, so we don't have much of it left in the Earth's crust. But again, all Group 1 metals will react quickly with water. And when these Group 1 metals react with water, they will produce metal hydroxides and hydrogen gas. And it's this hydrogen gas that catches fire when potassium is added to water. All Group 1 metals produce soluble hydroxides, which is where we get the alkaline solutions from. Now let's take a look at the reaction when we add a Group 1 metal to water. So any Group 1 metal plus water will produce the Group 1 metal hydroxide plus hydrogen. I can give you guys a more definitive example. For example, sodium. Sodium is a Group 1 metal, and when we react sodium with water, it will produce sodium hydroxide and hydrogen gas. Remember that sodium hydroxide is soluble, which means the solution will be an alkaline. But you could also be given the symbol equation and asked to balance. So the symbol for sodium is Na, and we've put a small s because sodium is a solid, and we're going to add it to water. Our water is a liquid, so we give it the state symbol L, and this will produce our sodium hydroxide, and we've said in previous videos that this is soluble, so we give it the state symbol AQ, and we're also going to produce some hydrogen as a gas. Now this equation will need balancing, and to balance this equation I put a big 2 before the Na, this balances my equation. And this equation works for any of the group 1 metals. Another point to add is that as we go down the group 1 metals, that their melting point and boiling point, it decreases as we go down. Another important reaction for group 1 elements is how they react with non-metal atoms. And group 1 metals will react with non-metal atoms and form an ionic bond. In previous videos we've covered ionic bonding, which is the transfer of electrons. If I just give you guys an example, if we have lithium, which has 3 electrons, and we're going to bond lithium to fluorine. Fluorine has 9 electrons. You can see here that I've represented lithium's electrons as crosses and fluorine's electrons as dots. And what's going to happen is our lithium atom is going to give its outer shell electron to fluorine, which is going to form ions. We're going to get charged particles because we've transferred electrons. Our lithium has lost electrons, so our lithium will become positive. It now has more protons than electrons, whereas fluorine atom has gained an electron, and you can see that electron is gained from the lithium. So because fluorine has gained an electron, it becomes negative. There's a strong electrostatic attraction between these oppositely charged ions. And from this ionic bonding diagram, you should notice that all group 1 metals will form a +1 charged ion. These group 1 metals, especially sodium, can be burnt in air to form a metal oxide. For example, sodium plus oxygen, as that's the gas that we're burning in air, will produce sodium oxide. Again, we can represent this reaction using the symbols. Sodium has the symbol Na, and we're reacting it with oxygen gas, and this is to produce sodium oxide. And hopefully you guys can see that this equation isn't balanced. So to balance the equation, I just add a 4 and a 2. Okay guys, thanks for tuning in. Stay in touch for another video.